Thank you. Yeah, well, it's quite crowded considering also the online participants, more than I anticipated. Welcome. Yeah, I want to talk about the importance of workflow engines in contemporary data analysis. And end up the title for admins because I anticipated that some of my fellow administrators and service providers are along with us, and HPC users or data analysts. I'm from the NHR Southwest in Rhineland-Palatinate, as Georg already mentioned, and I also represent the Snakemake Teaching Alliance, a loose alliance of some fellow developers. All right, I want to introduce you the reason why we ought to use workflow managers, and not necessarily Snakemake alone. There are, of course, various alternatives. And then I'll introduce Snakemake and its capabilities, how we handle software and what's in there for administrators and users. I show you how this can be launched when we get to work, and a little bit about the nifty details with regard to our workflow parameterization and how we can get from a generic workflow, which runs on a desktop or a laptop, onto an HPC system. So the first part is administrators, when they teach HPC 101, they teach the best batch systems to their users. And I want to put a question mark behind that. Also, I want to illustrate the benefits of a workflow system for administrators and the difference between a workflow system and a pipeline, and thereby introduce a little bit of Snakemake. Now, data analysis can be quite easy and can be conducted on a simple computer. However, in the light of rather big amount of data, this can be quite frustrating. Yeah. And just learning Slurm might not be the last and wisest move. And I'll illustrate you why. But first, you have to understand when we talk about data analysis, there are constituents which I think, and if you beg to differ and just interrupt me, are always or almost always present. That is quality control, processing, presumably multiple process steps in processing. Then you do some summary statistics, and then you want to publish. Therefore, you need to visualize, you plot something statically or interactively. Not all such steps, if we be honest, are HPC worthy. Yeah, because for instance, if you do an internet download or you move around and tinker with data, you get this to your a component to your program. That's something you can do on any computer. That's not what you do on an HPC system, not necessarily. But I want to argue that we can actually do that without a greater harm. For that, I want to introduce you a DAG. I know that many of you are computer scientists, you know that. A DAG is a directed acyclic graph, and that's an entity with which we can display any data analysis. When I talk about, you always see these little boxes, and you do not need to understand that here is a simple workflow. Yeah? So first for instance, in linguistics, we can count words and make a plot, conduct this to put this to a statistical test, then we can archive that. These are just jobs, not necessarily HPC jobs, but jobs, something which is carried out by a workflow manager or by the scientist doing this kind of analysis. Then a full DAG also takes into account that you have presumable multiple samples. Here in this little linguistics example where we count words in books, we might have several books, and then we count this in several times and subject this to plotting and one common test and one archive. And it can get extremely complex. I'll show you. If there are any questions, don't hesitate interrupting. So this is what you need to have as a background. Just basically every such box, if you can read it or not, doesn't matter. Every such box stands for a job. So I want to give you an example. This here is a workflow. It is what it does is simply some proteomics. So here we do some mass spec data analysis, and we subject this to some genome assembly and annotation. That's something which we can conduct on an HPC system, and it's quite HPC worthy because it's extremely compute intensive. Hence, what does it take to run this on an HPC cluster? And I can be proud of myself because I've been teaching all these intro courses for quite a while. And one of those students got to work and implemented this very workflow with Bash and Slurm commands alone. I'll show you how it looks like. So these are all the files. Here we go. Yeah. So all the files, you don't have to read it, but it's an heroic work. And I want to ask you, well, there are some 4,000, almost 5,000 lines in Bash, a little bit Perl Python, written by her extremely well, if you consider that. And I dropped some lambs which are there to identify her. So I can ask a question. It's totally self-graded. You don't have to answer. Yeah. How portable is this actually? How maintainable? And then again, how many of your users can you expect to accomplish this? Quite a minor fraction, right? Well, if they come and want to analyze the data, which conclusion will they draw if you tell them you have to do all that by yourself? So let them learn Slurm. Is this enough? I want you to contemplate, when do users apply for HPC time? When do users expect to analyze the data? What do users expect to analyze the data? So, and what will those users think if those expectations aren't met? So first of all, of course, when they are confronted with huge data or huge simulation needs. Anything else, the microbiologist with his tiny genome can work on a laptop device. That's today no big issue. Now, what do users expect to analyze their data? Of course, all the necessary software. They don't want to beg for it. No? They want just to calculate. They don't want to listen to all these complaints about IO issues or any other issues they might cause on a multi-user system, right? This is your daily experience, I presume. And they want to get their results fast. After all, now they are on a supercomputer. That's what they want, right? But then they have their basement server, and they just run their pipeline there, and that's not hassle. So all the workload on an HPC system and all the bureaucracy, and then they also, users don't necessarily plan, right? They just want to do their analysis. And how do you meet those expectations? Well, with software provisioning, data management support, curated workflows to some extent. Well, perhaps, and that's why I want to introduce workflow managers. Such workflow managers come to rescue. So it's the year 2025, and we want to have everything automated. From raw data to final figures, everything ought to be documented also. And we just probably want to press a button and then off it goes. It's not that easy, but essentially. You want to be the data analysis scalable. You have one sample, ought to run. You have 1,000, tens of thousands, hundreds of terabytes. It ought to run. On an HPC system, in the cloud, on a big server, it ought to run. And when you go from one institution to another, researchers move after all, they are confronted with different systems which are available to them, and they want to port their workflows. Also, this is a requirement for a workflow engine. Again, it's the year 2025. We are talking about open science, reproducible computing. I also now mentioned adaptability and transparent computing. This is the first part. We talked about it. There's a little bit more to it. It ought to be readable. We want to trace the workflow such that we understand what it's doing. It shouldn't be a black box. The auto documentation already has been mentioned if you want to be transparent. So here comes SnakeMake or Nextflow or Galaxy. But I want to focus on SnakeMake because that's what I know the best. So what's SnakeMake? How does it work on a cluster? A little bit about other workflow management systems. SnakeMake itself is quite popular. It's been conceived by Johannes Köster in 2012, and since now 10 years, we measure all the downloads, and there are over 1 million worldwide, thousands of citations, and it's gaining traction as we speak. Also, for my little Slurm plugin, I also measured a couple of 10,000 downloads already. SnakeMake was first introduced in bioinformatics, and meanwhile, more and more physics community adopted. I'm well aware of ab initio simulators and high energy particle physics and astronomy, as I learned today. So that's where it finds adoption. Users do not necessarily have to reinvent the wheel. SnakeMake, pretty much like Nextflow, offers a workflow catalog. Meanwhile, it finds over 3,000 more or less maintained workflows. Of course, it's academia, so sometimes it's published and forgotten, but anyway. There are more than 300 standardized workflows ready to use, meaning if they are standardized, they are documented and with automatic deployment. Cluster batch systems are supported, and we also have support for a number of cloud systems, but I presume you are not necessarily interested in that. You can combine SnakeMake workflows with Nextflow workflows also, if you are really keen to do that. Nextflow and SnakeMake basically are workflow managers which are triggered on the command line. You simply write SnakeMake, some arguments, and then the workflow will start. Users merely need to fill in parameters for their workflow, like any configuration, where to find the data, obviously, and then all the scientific parameters. Usually, the workflow comes with a template with sensible pre-configured parameters, but your specific workflow might require something different. Then you need to alter the configuration, obviously. It can log in onto a login node of a cluster, and then you spawn your jobs on the cluster using a specific cluster configuration file, which might contain, and I'll show you later, some defaults like your Slurm account or a default partition or something like that. It's also capable of removing temporary files. You're well aware that data management on big systems is an issue. Many files generated during a workflow are intermediate files. They can be automatically removed. And there is support for various archiving systems, but I'm not going to focus on that, not today. Spawn jobs on a cluster. I hope that you are familiar with HPC systems. So basically, that's what I explain in greater detail in a 2-day course. But here you get the admin background. So you log in onto a login node, and then you trigger SnakeMake. SnakeMake will submit jobs for every task it encounters. And then it keeps running, basically without any noticeable CPU load. So if I monitor that for a few hours, I just have a few seconds of CPU load. And it sits there. You can also take an interactive job if you really want to and launch it from there. Depending on the workflow, it might have additional jobs which are carried out on the login node itself, like a download of reference files. So I'll present you later some pharmaceutics workflow where we screened millions of small molecules, and those needed to be downloaded from a database prior to launching the workflow. Something we couldn't do on a cluster node because these didn't have access to the internet on the previous cluster, hence on the login node. And again, the CPU load itself is manageable. And then some final plotting, also hard to notice. So this is this workflow I just mentioned. This is a quite ordinary workflow, I'd say, where we have all these rules here, all these jobs here, where we have many of those. This is kind of 90% of the work. And you just have a few HPC jobs. And then you see this little box here labeled docking. And that is 90% of the compute time. Then we trigger an MPI program and it does this. Pretty much like the Viking people from further in the north, which we listened to the other day. Anyway, so SnakeMake now reacts on the input. If we have more input, more samples, then more jobs are spawned accordingly. Here we don't have necessarily I/O contention, but SnakeMake also offers a remedy to I/O contention, which I'll show you in a minute. And I'll also show you how to do a little bit of real-time computing with cluster support. And you can do your analysis from A to Z, from the input of your machine, your experimental machine, up until the publication-ready reports. So now one of the big issues administrators face, how do I provide all this software? Because any generic workflow might use a dozen or so packages up until a few hundred, and this needs to be installed somehow. So this is what I want to talk about just for a few minutes. What kind of software provisioning support is integrated into SnakeMake? Basically, SnakeMake offers 3 deployment methods right now. Containers, like with Optainer Singularity. You're familiar with that. Or environment modules, which is rather tedious, or Conda, and its derivatives number, you just name it, Pixie. And we are currently contemplating to provide support for ESI, the European Sustainable Software Initiative, also provided by the CERN, where we can have CPMFS mounted on our compute nodes and then have a Conda to ESI translation eventually, within a few months, hopefully. Now, how is it done? Conda, in a way, is preferred by the SnakeMake developers and therefore portable. Sometimes it's insufficient. We do not necessarily care about performance when we do a plot, but our MPI program or numerical library, it ought to be performed. Then you can just combine software deployment methods with a simple flag, which you can also store in a configuration file. We don't have to always type that. So you can say, I use environment modules where they are not specified, fall back onto Conda. And then you have to specify your environment modules for the couple of rules you want to compute. With the SnakeMake Teaching Alliance, we first show how to install software into an environment, and then one environment per workflow. That's the preferred way, because then we can just contain that. Eventually, we also show how to delegate that software installation process to SnakeMake, because it's not something the user or the administrator has to do. If we ask for SnakeMake to install the software, SnakeMake will do that. And all you need is a very basic environment. So basically, the basic deployment method is Conda. Conda delivers statically, generically compiled libraries and applications, hence comes with a performance penalty. You can always switch for like your MPI program or a container, which you prefer, but that ought to be an exception. And we are working currently on mitigating performance issues. I already talked with a few of you before that. I want to show you how does SnakeMake work, basically, before I show you some. So which features are provided and how do we write and select a workflow? So basically here in bold, where's my marker here? SnakeMake is rule-oriented and data-centric. We define input and output for every rule. Always note there are some exceptions with input-only rules and output-only rules, but that's the rule, so to speak. And each rule, each sample consists of a job. Now this is hardly readable, right? So we can make this a little more readable and scalable with using wildcards. And now in bold here, for every sample ending on this suffix, whatever that is, now a job will be spawned. We are also able to trigger not just shell commands like we've seen, but script commands. And with that, we can refer to any scripting language like Python, R, Perl, etc. As SnakeMake is Python, we can code small snippets within SnakeMake in Python. Yeah, any pure Python code will be supported in this environment. We all know the quirky program where we need to fiddle for quite a long while to get it running. SnakeMake offers a wrapper library, and if you specify such a wrapper, and the documentation is easy to digest, SnakeMake will automatically download a wrapper and handle that otherwise quirky program for you. Already mentioned, by providing conda specifications, we ensure that the workflow is portable. We actually kind of require workflow writers to include conda directives like this one here, such that it's really portable. However, you can always fall back onto an environment. Essentially, Python is just a little bit specialized. SnakeMake is just a little bit specialized Python, and hence you can always use Python methods like to collate your data, arrange it, and then you have here like a function which can have any Python body, and instead of defining a file, you can use a function instead. The claim is that although it's rather complex, there are helper functions which provide an easy readability, like, for instance, this branching functions. Yeah, so you look up this path, is it there within the config? Yeah, then the input is this, and otherwise it's some other data, and then you work with it. So you have an internal branch in the workflow. Of course, it can be more sophisticated than this tiny example. We administrators and scientists alike, we struggle with sometimes with the need to account for ad hoc computation, where people produce huge amounts of data, for instance, on a confocal microscope or a scattering detector and whatever. And here we have the ability also in SnakeMake where we can, for instance, mount a cluster file system somewhere else, export it by Samba or SSHFS or whatever, and then put some data on there. We trigger the workflow. The workflow will recognize there is new data, and it will start analyzing, submitting HPC jobs. This is then, of course, not real time, but almost real time, provided that you get a job in the queue. Also, the checkpoint here allows us to adapt a workflow during runtime. Right, I made the claim that when we launched SnakeMake on a login node, it's rather generic and we don't want to tinker with that workflow somebody else has written for a particular program, a particular scientific problem that is, because we trust this solution, and all we need to do is we change some parameters. However, we want to launch it on an HPC system, and here we can have a simple YAML file. So this is from the computer where I work on. I simply define some default resources like the Slurm account. The way I've written the executor, it's able to guess your Slurm account, but it's not always fail-safe. You can have multiple and then it can't decide. The Slurm partition, which may be default. So for default, I go into all my small jobs go in some small partition, and then the bigger jobs like this one here into another. I can also define some memory. It's also quite capable of digesting units. And then I specify deviating resources for those rules which require higher resources than the one just specified. For algorithmic reasons, we need to specify threads or something else down there. I'm currently working in automatic pooling of small jobs, so with 33 or something threads, it's not necessarily merited to go in a big partition, but if I have like 10 or so, then I already require 300 something CPUs, and hence it might merit this. So just briefly, what does the Slurm plugin for SnakeMake provide? And I should mention that we have a similar plugin for LSF and HDConder, and but submission of jobs and status tracking. Status tracking is we do this by the job name, and that for all the jobs we spawned. We have a distinction, or we can make a distinction between the cluster jobs and the local jobs, as mentioned, like for instance, when we do visualization. I coded an auto cleanup of Slurm logs. Usually when you conduct a long data analysis and you spawn a zillion of jobs, you have a zillion of log files. For a successful job, this is not meaningful to keep, henceforth it's automatically deleted. Again, one data management problem less. We have multi-cluster support. I know that here in Erlangen this is solved differently, but there is multi-cluster support available. There's feature selection with the constraint flag if you need a special feature which is not a generic resource. We have improved CPU binding. It can retry jobs, failed jobs. I'm currently working on memorizing failed nodes. Presumably you have something like a node health check here in Erlangen, which takes failing nodes out of the queue, but sometimes you still need that. Some clusters exercise job preemption. SnakeMake can cope with that. There is currently no support for job arrays, Slurm job arrays, but it's in development. Actually, I just took the break and tinkered with the code already. And later this year, I want to also auto pool SMP jobs and release that, such that we can have one pooled stage in, let's say, for instance, of a reference of a few hundred gigabytes for a local aligner in bioinformatics. And then you just launch that and you can have 50,000 jobs or more aligning several million sequences, 100 million sequences within the hour. Basically, it's done, but it will take some time to release. Now, also IO pattern annotation. Right now, we do a catch all stage in and out, which I'll show you. I want to be a bit specific. We can launch MPI jobs. For instance, you have here GROMACS, MDRAM, MD, whatever, you know that program presumably, and you can launch this with srun or srun -- something, whatever you want to. And I want you to remember we can specify all those resources in a file too. We don't need to alter the workflow itself. Some programs don't work well with srun. There are some which have a kind of a broken MPI, and then you can still switch back to MPI exec or whatever, MPI Hydra or something like that. We are confronted with more and more people who do machine learning. And of course, the executor is capable to support that, either with the GRESS flag or with the GPU's flag or GPU model flag. But I don't show you all the nifty details here. I just want to mention that it's capable of doing so. And we can select multiple CPUs per GPU and multiple GPUs accordingly.
These keywords, GPUs equals and GPUs per GPU equals, are these SnakeMake keywords that are translated into whatever backend scheduler you have?
Yeah, you're right.
Okay.
Right. Yeah. That's I could dub it like anyone, but this here is now exactly the same lingo as Slurm has, but that's kind of a convenient coincidence. Now I talked about IO contention already. Let me just show you how to avoid this and file system latency. During a course, I would talk about random access. Are any bioinformaticians amongst us? In bioinform, yeah, sort of. Yeah, you know that when you have an aligner, it doesn't necessarily do random access because it walks over a big database, right? More or less big. I'm just putting local and global aligners in one big box, yeah. But when you have multiple instances and they start at different points, blocks in the file system at different time points, from the view of a file system, this is random access. And this is what a parallel file system is not really designed for. Henceforth, we want to have a solution. And for this, we use profiles, and now we can have an easy remedy for IIoT use. A global profile can be defined system-wide. So an administrator might decide, I want to support SnakeMake for our users, and I store this, for instance, in etc, like this here and here, or the default will here every home of a user. Which one you have will be answered if you invoke snakemake-help. A workflow-specific profile can be defined with this flag -workflow profile, which can contain the same information. I can write on the command line --executors shall be Slurm, and then all the jobs are Slurm jobs. Or I just put this in a configuration file, and then no user anymore has to type --executors Slurm. On a parallel file system, SnakeMake will decide when a job finishes, is this file actually present, which should be generated as output, and if not, it will fail. But we can say, well, there's some file system latency, like here 5 seconds, this is ample time, and if it's not there after 5 seconds, you still have the chance to fail. Now, all the rest here is supported by the storage plugin for file systems. And here we have like shared file system usage for those cases, persistence for sources and to cache. And we can make the distinction there where we run locally. This might be devshmem user, yeah, my username for any temporary file we need there. And this is more important for remote jobs, because from the login node, every HPC job is remote. And this here is just the one we have on our cluster where I work on. We have /local scratch /slurm job ID. This here is an environment variable. It's automatically recognized and replaced by the executor on the compute node. And hence we can do a copy statement for our files. For instance, on a local stretch on an SSD, or alternatively onto a RAM disk, which we require. And that gives, of course, a much better performance. Again, we can require users to install this in their home, or we can provide this globally, either on a global default path or on an alternative path, which you might have on a cluster, and then you simply state an environment variable where Slurm ought to look. I'll show you an example. So this here is an example call. So I'm in my home directory where I downloaded the workflow, and I write snakemake -j unlimited. Unlimited means spawn as many jobs as you want to. Well, now, which are spawnable according to the workflow. It can also be limited, like a low number, like a dozen or so. Then I have my workflow profile in some kind of directory, the config file, which is the sciencey part, where I have my parameters, and then my directory. Because, well, it's perfectly fine if I have my scripting code and the workflow isn't big in my home directory, right? But this is not necessarily where my data reside. Hence, this here is not on home. It might read something like /lustre /project workspace, whatever. And then that might be the workflow, the software deployment method, Conda, or environment modules, Conda for the few environments modules I have. Please clean up all the packages. The Conda prefix, the Conda prefix might also be on a different locations because you might be dealing with file quota in your home. And then you just specify a different prefix and clean up later. The software stack is, of course, SnakeMake itself, including tools like GraphViz and so on. The executor for your respective batch system, I presume Slurm here. A storage plugin, the interface here. A report plugin to generate reports. I'll show you in a minute how a report might look like. A storage plugin for stage in and out. We are going to boost this a little. And for automatic wrapper support, the wrapper utils plugin. If you install that, all the dependencies are also automatically installed, either via PyPy or Conda. Now, if you want to learn how to create and publish SnakeMake workflows which conform to cluster specifications, and you want to learn how to deploy and adapt third-party workflows or more, then I'll be conducting courses in Mainz. So when we ship the slides, you find the links, and in Dresden later in February. I wanted to show you just briefly. It might look like I'm not quite sure. Yeah, I'm still connected. So I can produce a duck, or I can simply produce a report like that, and also show you what it takes to start running. The F simply means take a forceful execution, don't look back. And now it starts running and spawns jobs. Meanwhile, we can have a look on, I tested, aborted, kept a log file. This is what's not pleased with. This is a security feature. I of course don't want to override. Okay, and now it starts submitting jobs so fast. And if I scroll up here, a total, that's a nice sum here, a total of 100 jobs will be submitted in this case. And it will run for several hours because these are really big data. And I'm not going to show you all the execution. I show you the duck. And you can see almost nothing, right? It's for all the samples I have. And if I zoom in, we see that it's mapping reads onto a reference genome. You don't necessarily need to know what that is, but there are plenty of such jobs, and there can be more. If the sample size increases and there are more samples, then there are more jobs. And it's quite intricate. You see that there are many dependencies to solve until the entire workflow is conducted. And that's why we need an HPC system. Yeah, it's compute intensive, it's complicated, and we need to conduct this on an HPC system.
So it use the Slurm, if it uses Slurm, does it use the Slurm dependency feature to define dependencies between jobs? And if there's no such feature, it just uses the job controller or whatever on the front end?
The dependency resolution is done by SnakeMake according to the DAG. You might think of, well, if I submit a job prior to execution with the dependency feature, then it can accumulate fair share or priority and then start sooner. But we never know whether a job will fail or not. And henceforth, we don't do that. And it needs to be conform, and it needs to be portable. And whether we want to compute in the cloud or on an HPC system, not all systems provide the same features. That's kind of tricky. And if you look on that, the number of jobs doesn't necessarily define the compute intensity. So we have here a few gigabyte of long read data. These are thousands of bases long. And what we'd want to do here is find out which are differentially expressed in which, how does nature tinker with it? Yeah. This revolves around mosquitoes, but I'm not going to go into that. This is what a master student of mine just did here. And here we have some tiny rule. Apparently, there is no wall time information given. Henceforth, the executor is complaining, but it ought to finish in a few minutes, and therefore the default runtime is just fine. It will also report how far it got, which is kind of a rough estimate only with regard to runtime. In the end, we can ask SnakeMake to generate a report. How is it done? You have this command line like before, and you write -- report. That's all. And then you get an HTML file like this. Here we have the duck again as some hardly readable display. Here, plot samples, and then you see the software, the code it uses, and the function is here in input, or we can say, extract genome has this piece of software in unzip, and then it unzips something. We as scientists, of course, are more interested in results, like for instance, if I click here onto the correlation matrix, I see the figure SnakeMake produced, and I see a description which is almost that which I can copy paste as a caption to the figure in a paper. We will also get some meta information, like how does the rule look like? This is the code behind that. That's a rather intricate Python script. Come on. And then we see all the software, including version specifications, which we asked for, which we protocol, which we can use during the publication. And also in the bottom, is the peril of a tiny screen. I need to go back here and simply say, I'm going to go to the bottom. So here, all the samples which we used. And then, of course, the researcher has to know what do all these samples mean. And it's kind of wrapped here on the small screen, but usually quite readable.
How do you specify that a figure like that, which is part of the output of the workflow, has to be integrated into this HTML report? Produce 1 million figures, but none will be in the report. So how do I say that?
Right. For every figure we want to be included in the report, we need to have a report directive. And for every caption we want to have, we need to have an RST file. It's not automatically so. Usually to develop a SnakeMake workflow or an extra workflow for that matter takes the amount of a master thesis. It's not something you do in your lunchtime, I'm afraid. That's a jolly good question. We also get some statistics, but this is kind of meaningless because here in this kind, when I produced this, I had some days in between. So therefore, the spread in execution time is not meaningful. We also have some additional figures here. I'm not going to show you because it takes a long time to plot. It's like this. We can also just visualize. And it takes quite a time to display because I have a zillion of dots and that takes a little while. So we have all the scientific figures. We have everything we need. Now we just need to interpret and publish.
Can that be automated?
Huh?
Can that be automated?
Ask the friendly AI people. Yeah, it's people who do that, but in my experience, those papers aren't very readable and also not reliable. Okay. We can't automate everything. That's kind of a self-portrait of mine. So that's when I do course announcements. And with this, I'd like to come to an end. And thank you for your patience. I've been running away. I've been way over time. But anyways, so that's where we are. Are there any questions? Of course, this was quite a gap.
I don't know you're the right person to ask, but since you told that this tool originates from the need of informatic people, right? So it generally involves data engineering and analysis, if I'm not wrong. There are other tools, right? Prefect or Apache Airflow, so they also have this Slurm integration and support. So how does it compare with them?
I dare say that SnakeMake and the strongest competitor Nextflow are the most generic workflow managers. Perhaps to some extent also Nyman and Galaxy, but there you need to have much more input from the administrative side to actually conduct all the analysis on the cluster. There are workflow engines which are more tailored to a specific scientific community, like, I don't know, what was it?
Apache Airflow and Prefect.
Yeah, Prefect, for instance.
Mostly these are used for data engineering, also with like pipelines.
Yeah, and then of course we have something like DAX and astronomy people have their own, came up with their own tools already years ago, but it's not as generic as those which I mentioned, SnakeMake and Nextflow. Yeah, and then I just showed you a very tiny glimpse on the feature set.
With a workflow, you're abstracting away a lot of details from the end user, and it bears the potential of bringing a cluster to its knees at the click of a button.
Yeah, that is.
Does that happen a lot?
I'd say that people won't use this a lot more than here in Germany, from my download figures also, because, that's politics. We are also, as a community, right now developing a GUI for SnakeMake. It's already possible to launch like a Jupyter notebook at the end to adapt your figures if you really want to. We are getting there. Basically, the configuration file, this is, or the workflow profile first. This is something you could write. You could simply say, well, you go with all the jobs in this partition, then I look in, this is causing some trouble. You go somewhere else, yeah, and calculate there, this is a bigger job. Well, you perhaps not, because you have this cluster distinction, but basically you could do that, yeah. Like for high memory jobs, you go in a different partition. Do your genome assembly, or your when you base calling, you go into a GPU partition, and then when you do machine learning, you go there too. Calculate with Gromix, Plum, D. It's also a GPU partition.
One question. As far as I understood, I have to define the runtime for each of the jobs that is in the DAG. Is this correct?
So let me rephrase. Do I need to specify the runtime for each job?
Yes.
No.
So how does the
just have a
cluster-
default, and you go by that? And some jobs will require a longer runtime. Now there are two cases. Either you, as a user, have to realize it's going over the wall time. You might have a couple of reasons. Yeah, like for instance, ill performance due to some iOS issues because the parallel file system just crashed, then you can't bloody well do anything, or you realize it's just taking more time and then you adapt the time. Or if you're lucky, the workflow designer already anticipated this and has some automatic adaptation built in. Does this answer your question?
Kind of, and it imposes more questions.
Sorry, I didn't get it.
Yes, so if the runtime of one of the jobs in the DAG, for example, I have a certain data set, and data set 1 needs 2 hours to be calculated, data set 3 needs 2.5, and data set 4 then whatever 4 hours, and the default is 3, then I have one data set where the default is not working, but the others are fine. So what do I do?
In a well-developed workflow, in an ideal world, every workflow would be well-developed. In a well-developed workflow, there is already automatic recognition of, let's say, input size, and then memory and runtime specifications are auto-adapted. If not, either you just submit a patch, or what you do as an HPC user always, you just have an idea how much runtime you need to. You go a little bit over that runtime just to be on the safe side without losing too much of your fair share, and then you start submitting. If you oversubscribe with your resources, you just have a penalty in terms of priority. It won't harm you any further.
Yeah, all right.
That's my take. Of course, but when I'm dealing with my students, I just try to press that they have some auto adaption there. They realize, okay, I have a scaling figure like gigabytes times for this particular 2 times 0.5 gives the amount of time I need to crunch this data, something like that.
Yeah, just a follow-up as actually SnakeMake user on that question. The good thing is, of course, also if you not have a well-developed SnakeMake workflow, the next time it runs, it just needs to reprocess that one job that runs over it. That's the surplus that I'm telling to my students. You don't have to run the whole workflow, which you will do if you have a simple batch job, right? Or batch system running, which is setting it.
So for instance, I'm just terminating here. We are at about 35%, which are finished. I have a crash, I induce a crash, and if I restart, I just simply issue rerun incomplete, SnakeMake will calculate the duck. It will realize nothing has changed in terms of the environment, in terms of the rules, in terms of the parameterization. Henceforth, I can still trust all the files. And let me just look, I presumably crashed a few. Here you see, I'm not going to submit 100, I'm going to submit now 1/3 less, give or take. Thank you for that remark. I completely omitted this feature.
All right, more questions. Yes,
Question my side. This is quite tedious to see. So as a user, is there a way to see the graph as it goes on completing? Like I can see it live, where it updates all the items which are completed, mark as green, or which are currently running as yellow, or so on, or which are not completed gray, or something user intuitive experience I can have.
Right now, with the complicated workflow, I would simply open, which I don't have in the presentation, a second terminal and invoke it and plot the duck, and then it will display which rules are finished and which are still to be conducted. But that's not as interactive as you might wish for. But still something we can come up with.